This 6-story structure is not a factory or a workshop, it is the engine of the world's largest LNG-based container ship. From the inside, it is so massive that workers can easily walk around inside it. This engine drives a propeller whose height is equal to that of a double-story house. And obviously, since it powers a container ship, it must consume a huge amount of fuel. But how much exactly? Just during startup, it consumes nearly 100,000 liters of fuel. Surprisingly, its fuel tank is so large that 6 Olympic-sized swimming pools can fit inside it, and it can store up to 20 million liters of liquefied natural gas (LNG). Today, you will learn about a mega project that has literally pushed the limits of human engineering. Once again, although we are living in the 21st century, even today 90% of international trade is transported via the oceans, whether it's something as small as a needle or as large as a car. To understand the scale, flight radar data shows that at any given time, 15,000 to 20,000 airplanes are flying in the sky. But if we look at marine traffic, at the time this video is being made, an astonishing 38,000 cargo ships are sailing across the world's oceans. When it comes to the size of cargo ships, humans have already built some extremely massive vessels. Even larger ships could be built, but then they would not be able to pass through major canals like the Suez Canal and Panama Canal. Therefore, the competition is no longer about building bigger ships, but about building more fuel-efficient ships. And that is exactly what the French shipping company CMA-CGM decided to do. They wanted to build the world's largest eco-friendly ship, one that would not run on diesel or heavy fuel oil, but on LNG liquefied natural gas. This ship is 400 meters long, equivalent to placing 4 football fields in a straight line. Its width is 61 meters, and its height is taller than the Qutb Minar. The total weight of the ship equals 7 Eiffel Towers or 11,500 African elephants, about 70,000 tons, even without containers. The ship can carry a total of 23,112 containers. To imagine their scale, if all these containers were placed in a single line, they would form a queue 150 kilometers long. But the real challenge was not just building this massive ship. CMA-CGM had to build 9 such ships, and that too within just 2 years. For this task, a shipyard in Hong Kong was selected, stretching over 4 kilometers, resembling a small city. Around 6,000 workers from across the world worked day and night, each assigned a specific task. Normally, it takes about 18 months to build a single ship. So how were 9 ships built in just 2 years? The simple answer is modular construction. The ships were built in sections known as blocks. The foundation of a ship consists of special steel sheets that resist corrosion. Each ship required 12,660 steel sheets. These sheets were cut using a special laser beam with a temperature of 18,000 degrees Celsius, which is 3 times hotter than the surface of the sun. The laser cut through steel like a knife through butter. For a single ship, 880 kilometers of steel plates were cut. These sheets were then assembled into blocks. Some blocks were the size of the room, while others were as tall as multi-story buildings. Remarkably, these blocks already had pipes, wiring, and other fittings installed before assembly. This is the rear section of the ship, constructed by joining 5 blocks. It weighs 790 tons, equivalent to 2 train engines. To lift it, 2 joint cranes were used. The block was placed onto the ship's structure with extreme precision. Even a 1 mm error could ruin months of hard work. Once all the blocks were positioned, an endless process of welding began. Astonishingly, a total of 1,250 kilometers of welding was done on a single ship. If laid in a straight line, this welding would stretch from Karachi to Lahore. Each weld was carefully inspected because the ocean's brutal waves forgive no weakness. So far, this was just the story of the hull and structure. The real marvel lies in the engine. This ship does not run on traditional oil or diesel, it is designed to run on LNG. This is a major environmental victory because LNG emits 99% less sulfur dioxide, 91% less air pollution, and 20% less carbon dioxide compared to conventional fuels. However, bringing this revolution to the shipping industry came at a heavy cost. The biggest challenge was storing LNG in liquid form. LNG must be kept at -161 degrees Celsius. If the tank warms up or insulation fails, LNG turns into gas and disaster follows. The ship must travel from Asia to Europe without refueling, requiring an extremely large LNG fuel tank. Surprisingly, this is the largest LNG fuel tank in history, with a volume of 18,000 cubic meters. It can store nearly 20 million liters of LNG, equivalent to 6 Olympic swimming pools. The real challenge was not building the tank, but insulating it from heat. It was like building a giant thermos flask inside the ship. It took 9 months to construct the tank, applying multiple insulation layers to protect it from external heat. After construction came the critical leak testing phase. Workers applied soapy water to joints and used a vacuum test. If bubbles appeared, leaks were identified and repaired. After testing, the final insulation layer, a 1.2 mm thick steel membrane, was applied. Its wave-like design allows the steel to expand and contract without breaking at extremely low temperatures. This technology is also used in space stations. After 8 months of hard work, the world's largest thermos was finally completed. Now comes the engine, the largest natural gas-powered engine ever built. It is 20 meters tall, equivalent to a 6-story building, weighs over 2,000 tons, and produces 85,000 horsepower. It is so large that maintenance staff can walk inside it. Transporting the engine itself was a massive challenge. It was delivered in 6 separate sections. Its most critical component, the crankshaft, weighs 220 tons and was transported using a remote-controlled platform with 140 wheels, then installed with millimeter-level precision. The engine contains 12 pistons, each with a diameter of 1 meter. It drives a one-piece cast propeller weighing 92 tons and standing 10 meters 33 feet tall. The propeller shaft must be perfectly aligned, even a small deviation could cause vibrations at high RPMs. Engineers use special blue dye tests to ensure perfect alignment. Once the structure was complete, the ship was coated with a special marine paint to protect it from saltwater corrosion and reduce fuel consumption. About 1 million liters of paint were used, covering an area of 9,500 square meters, nearly double the area of Vatican City. Finally, the command bridge, the ship's brain, was installed. The ship is equipped with a 360-degree smart eyes system, giving the captain full visibility. After 18 months of relentless effort, the first ship was completed. During 15 days of sea trials, every system was tested: engine speed, emergency braking, navigation systems, leak checks, and anchoring. Each anchor chain link weighs 300 kilograms, and the full chain weighs as much as 60 African elephants. All trials were successfully completed. The dream of low-carbon emission ships became a reality. One by one, 9 massive container ships were completed in record time. This is not just the story of building a steel giant, it is the story of thousands of workers, their dedication, and tireless effort. These ships are now ready to rule the oceans in a cleaner, greener way. They prove that when humans are determined, even mountains of steel can be moved across the world's harsh seas.